Hello viewers, in this video we will learn that what should we care of while dealing with the products of operators. The first point is that we should care of the order of operators while applying the product of two operators or any state vector or state function psi. That is, if we operate AB on a state vector psi and we operate BA on a state vector psi, the answer will not always be the same, because the product of two operators is generally not commutative. In some cases it does commute. For example, the exchange operator P commutes with the Hamiltonian operator, and that's why this exchange operator is called the constant of motion. The second point is the product of operators is however associative. That is, if we multiply B and C first and then multiply by A, the result of BC, it will be the same as if we first find the product of AB and then multiply that resultant, that product by C. It doesn't matter, the answer will always be the same. Point number 3, we may also write n times A into m times A is n plus m times A. This is exactly the analogous of the algebraic rules for variables, that is, the exponents adds up in case of same basis. Point number 4, when the product AB operates on a kit psi, the order of application is important. B acts first on kit psi and then acts on a new kit B psi. That is, if we have to operate two operators A and B on a state vector psi, we have to first operate B on psi and then operates A on the resultant we get by operating B on state vector psi. It is exactly like if we have A and Hamiltonian, so Hamiltonian will give E times state vector psi, so E will comes out and then A will operate on psi. Okay. Similarly, when the product ABCD operates on a kit psi, D acts first, then C, then B, and then A. Point number 5. When an operator A is sandwiched between a bra phi and a kit psi, it yields in general a complex number. That is, if you put an operator A between bra phi and kit psi, it will give a complex number. How it will give a complex number is, we know that the state vectors or the state functions are complex numbers, complex elements of the Hilbert space. So if we operate A on psi, for example, it gives A psi, then A we bring A out of this scalar product and we will left with the scalar product of phi and psi. As these two are complex numbers, so its product will give a complex number, but not always. In some cases it may be purely real or purely imaginary numbers. What does mean by the purely real? The complex number whose imaginary part is 0 is known as purely real, and whose real part is 0 is called purely imaginary. Note: in evaluating this quantity, it does not matter if one first applies A to the kit's eye and then takes bracket. Bracket is that inner product. That is the Dirac notation of the inner product, scalar product. Or one first applies A onto the bra and then takes a bracket, that is. It means if you operate A on psi first, or you operate A on the bra first, the answer will be the same. Okay, thank you. If you understand these properties of the products of operators, kindly please like, please subscribe my channel and press the bell icon to get more interesting and understandable videos on quantum physics.